The speed of a kayaker is 5.7 miles per hour paddling with the river current and 3.25 miles per hour paddling against it. All right, if you've ever swam or boated in a moving body of water, you know that if you're going downstream, the water is helping you to move faster in the direction you intend. But when you're going upstream, the water is working against you and it makes it harder for you to go in the direction that you wish. So whenever we do a problem like this, we have two speeds. We have the speed that you're traveling as if you were in still water, so that's the speed at which you're kayaking. And then you have the speed at which the water is moving, which can either be working for you or against you. So we're going to let K equal the speed of the kayak in still water. So that's the speed of the kayak relative to the water. So ignoring the fact that the water is itself moving, just the speed at which the kayak is moving through the water. And then we have C, which is the speed of the current. So that's the speed that the water itself is moving at. And these two things can combine or work against each other to create the speed of the kayak relative to someone standing on shore looking at the kayak. So when you're paddling with the river current, the speed of the kayak is added to the speed of the current because the two things are working together. So we can say the speed of the kayak plus the speed of the current is equal to the 5.75 miles per hour that someone on land would observe the kayak as moving relative to land. But when we're going against the current, the speed of the kayak minus the current results in the kayaker only moving at 3.25 miles per hour relative to land. Now, we always start with the kayak speed minus the water speed, because if the kayak isn't moving faster than the water, then the kayak's actually going backwards and it's not going to be a very good trip. Looking at these two problems, this is set up nicely to be an elimination problem because notice the C and the negative C are already an opposite match and we're ready to add these two equations together. We have 2K equals 9, and if we divide both sides by 2, normally I would want you to leave that as 9/2, but notice the problem started out with decimals. If it starts out with decimals, we're going to go ahead and answer in decimals. So we have found that the speed of the kayak in still water is 4.5 miles per hour. And if we then substitute that in somewhere in the problem, it doesn't really matter where, so I'm going to go here. I have 4.5 plus C equals 5.75, and if I subtract 4.5 from each side, I have C is equal to 1.25. So we can conclude that the speed of the kayak is 4.5 miles per hour, and the speed of the river is 1.25 miles per hour.